Okay, ladies and gentlemen, let's finish up our discussion of the Hinge theorem. Discussion of the Hinge theorem, we want to do some examples. Now, here's our first example. In this case, we have five as a side and four as a side. Five as a side and four as a side. So I have two sets of congruent sides. That's good. Now, the third side is 6 in this case and 6.2 in this case. So if these two are the same and these two are the same, but this one is longer, what can it tell us about angle A and angle D? Obviously, the answer is that angle A is smaller than angle D, because if this side is smaller than this side, this angle must be smaller than this angle. Now we can work it in reverse as well. I have this side congruent to this side congruent to this side, but you can clearly see that this at 120 degrees is way bigger than this at 20 degrees. And so what's got to be true about CB compared to DF? The answer is that CB is going to be way greater than DF. Now, those are some pretty basic examples, the Hinge theorem and the Hinge theorem converse, because we're taking it and we're reversing it. We're saying, if the sides are different, then the angles are different, or if the angles are different, then the sides are different. They're reverses of one another. Now, in this case, example 3, what can we say about angle B and angle E? The answer is nothing. We can't say a thing about them, because although I have congruent sides here and congruent sides here, angle B is not between. It does not qualify for the Hinge theorem, because a hinge, if you'll remember, has two sides with the angle in the middle, okay? So in this case, the angle is off to the side. So whereas this one's in the middle, this one's off to the side, we can't tell a thing about those. Nothing is known. Now, by the way, how come we also can't prove that these triangles are congruent? Well, I have a set of sides and a set of sides, but I have 0 angles and 0 other sides, and I cannot prove anything by side. Now, let's look down here at example number 4. In this case, what can I say about BAC and DAC? What can I say about those two angles? Well, the thing is, I have to have two sets of congruent sides. I have one pair, but where would the other set of congruent sides be? Obvious answer is AC is congruent to itself by reflexive. So now I have sides with angles in the middle. And if I say that DC is indeed larger, if I say that DC is larger, let's say this is an 8 and this is a 6, what must be true about angle DAC and ABC? BAC must be smaller than DAC based on the sides. Now, over here, what can I say about angle B and angle D without any additional measurements whatsoever? Well, they're congruent. They are, in fact, equal. The measures of those two angles are equal, or those two angles are congruent. Reason being, I got a set of sides. But here we go, folks. Reflexive says I got a set of sides there, so I can prove this triangle by side. So that's where we're headed with this. So if these two triangles are congruent, then that means this angle must be congruent to that angle. So a couple ways to apply the Hinge theorem to some of the problems we can work with. So give you an idea on how to go from there.